Hello everyone. In the previous video we have talked about addition rule of probability for two events. Suppose we have two events A and B, then the probability of at least one of them happening, we denote it by A union B. Sorry for this typo here. We denote it by A union B, and probability of A union B is given by PA plus PB minus PA intersection B. We have derived this thing earlier. And if we look at the Venn diagram, this event A union B is the shaded area in the Venn diagram. So we have seen that we add the probability of this circle A, probability of B, and then we subtract this probability which is there in the overlapping part, which is A intersection B, because when we add these two circles, this part is counted twice. So this is how we derive the probability rule for two events. And in the particular case, when the events are mutually exclusive, then event A and B cannot happen together. So we have the Venn diagram which looks like this. Because there is no overlap in the circle, we get A intersection B is equal to phi, and in that case we get this probability PA intersection B is equal to 0. So if I put it equal to 0 here, it becomes PA union B is equal to PA plus PB. So this is what we have seen. In the current video, we are trying to extend our idea for more than two events. So if we have 3 events, 4, 5 events, how can we get the formula for union of these events? So that we will try to derive. Now in case of 3 events, suppose we are working with 3 events here, A, B and C. So if we look at the Venn diagram, how it will look like. Initially, we are assuming that the events A, B and C are overlapping events. So suppose here is my event A, here is my event B, here is my event C. And I want to find out the probability of A union B union C. So definitely I want to find out the probability of this total area which is covered by these 3 circles. So circle A plus B plus C. So I want to find out this total area. So first of all, we can add up the probabilities of their individual events. So PA plus PB plus PC, as we have done in the case of 2 events. Now when we do that, we add these intersection area 2 times. So this intersection area is A intersection C. Similarly, we can see that this intersection area is the event B intersection C, and similarly we can say that this intersection area here is the event A intersection C. Sorry, A intersection B. So because when we are adding up 3 circles, we are counting these overlapping pairwise probabilities twice. So we need to subtract these pairs, probability of these pairs. So as we have done earlier, we can subtract the probability of A intersection B and probability of A intersection C and probability of B intersection C. So basically we need to subtract all pairwise probabilities. In case of 3 events, there are only 3 possibilities. Now when we do that, we have excluded, let me change the color of the ink so that it becomes little more clear. When we have subtracted these pairwise probabilities from PA plus PB plus PC, so in an attempt to do that, we have excluded this probability which is there in the inner circle. We need to add up this probability to get the required region covered, and this probability would represent, because it is common to all 3 events, so it represents the event A intersection B intersection C. So we need to add up the probability of this particular event. So when we do that, we get this formula. So basically this is the formula. When we have 3 events, so probability of at least one of them happening is given by PA plus PB plus PC minus pairwise these probabilities plus PA intersection B plus P intersection B intersection C. Now we can also look at the special case when the events are mutually exclusive. So if A and B and C are mutually exclusive events, in that case, we understand that there would be nothing in common. So how the Venn diagram would look like? It will look like three circles which are separate from each other, no overlap. So suppose this is event A, this is event B, this is event C. So in this case, it's quite obvious to understand that there is no PA intersection B. Probability of happening of this event is going to be 0. Similarly, probability of this event is 0. Similarly, probability of this event is 0. And obviously, probability of A intersection B intersection C is again going to be 0. So when we put all these probabilities to be 0, we get, in this particular case, what formula we get is P A union B union C. Probability of union of the events is sum of their individual probabilities. That's it. So this becomes very simple when the events are mutually exclusive. So this we have done for 3 events. Can you think about extending the idea for more than 3 events? Just take a pause and try to derive what you can do for 4 events, 5 events, and maybe n events. So how we will do for, suppose now we are doing for n events. First we will write the equation which will work in the general case. Then we will write the special case for the events to be mutually exclusive. So if we have n events and we are interested in finding out the probability of A1 union A2 union A3 and so on, it will go up to union AN. N can be any number, 10, 20, 30, whatever. So how can we get the probability? It would be equal to sum of their individual probabilities. This is the first line. We are just generalizing the formula which we have derived earlier. It would be not easy to visualize it for more than 3 events. So we are extending the idea. Now we need to subtract all these pairwise probabilities. Pairwise means pairs of 2 events. So we can write A1 intersection A2, A1 intersection A3, intersection A3, and so on up to A1 intersection AN. And this we have done pairwise with only A1 event. Similarly, we have all other pairs like A2 intersection A3 and so on. So we need to keep on counting all possible pairs. Here we are not talking about how many combinations we can have. There are NC2 combination, but just I'm giving you the intuition how we can derive the general formula. Now when we do that, we need to add up the probabilities of events taking 3 at a time. So A1 intersection A2 intersection A3 and so on. All possible events which are combination of 3 events kind of thing. And similarly we keep on subtracting the combination of 4 events and so on. So it goes on. We can write the formula. So what is the better way of writing this formula? We can use mathematical notation. Those who love mathematical notations can write it in this form simply. Probability of union AI, and I goes from 1 to n. So here this symbol means union is taking all possible values of union is for all possible values of I from 1 to n. We can put I equal to 1 or 2 or 3. For I equal to 2, it is simply A1 union A2 kind of thing. This is equal to, first we were having sum of individual probabilities. So my individual probabilities, I can denote it by the symbol PAI, and I am summing up all these probabilities for I going from 1 to n. Next is we need to add up the pairwise probabilities. So pairwise probabilities are AI intersection AG. So when we write I and J, both I and J can take values from 1 to n. So you can write equal to 1 up to n, or you can write belongs to 1n, or you can write in notation taking value 1 to n. We need to also understand that I is not equal to J here, because we are not writing intersection A1 intersection A1. Doesn't make sense to write that. So we just write I is different from J. So we can either use I not equal to J, or we can just write I less than J. One is the same thing. It means that I is a different index from J, and all possible values are taking from 1 to n. Next we need to add up sorry, next we need to subtract, this is minus here, next we need to subtract these probabilities of AI intersection AJ, and in the similar fashion I am writing some AK. K is a new index. Again, K is also taking values from 1 to n. So we can just write taking values from 1 to n, and we need to specify that all three indices I, J and K are different. So either we can write these are different indices, or we can give them some order. So in order to make sure these are different and going values from 1 to n, taking values from 1 to n. Then again plus sign, and similarly we can use another indices, we can add up these indices here, and using these notations we can keep on writing the equation up to when, because here we are having n events, and when we have seen the formula for 2 event, it was up to PA plus PB minus PA intersection B. So it was up to I going taking value from up to 2, and similarly for 3 events formulas was last term was this PA intersection B intersection C. So last term was including 3 events together. So here my last term would going to include n terms together. So how to write that thing? We can write this thing as we have written earlier, intersection of AI, where I again taking from 1, I again taking values from 1 up to n. And now we need to make sure that sign of this term is correct, because we are seeing alternate plus and minus sign. First term was positive. Okay, I have made a mistake here, sorry for that. First term is positive, second term it is negative, third term it is positive. These are alternate signs, sorry for the mistake. And this is again negative, next term is positive, and so on. So here what would be the sign of this term? Is it a positive or negative? So we can get an idea from these two rules that for individual probabilities it is positive. For second order probabilities, second order means A intersection B kind of probabilities, A1 intersection E2 kind of probabilities, the sign is negative. For third order probabilities, if you look at the rule in the previous slide, the sign here of the last term is positive. So we can get an idea that when n is an even number, then sign is negative, and when n is an odd number, sign is positive. So keeping in mind, we can use these kind of indices. If you have done some math, it's quite intuitive for you to think about how to write in terms of -1 raised power something. So I can write -1 raised power n minus 1 or n plus 1, doesn't matter. So whenever my n is 2, I am getting here 2 minus 1, which is 1, and sign is negative. -1 raised power -1 is negative. And when I'm having n equal to 3, I'm getting raised power 2, which is positive, and so on. So for n is even, I'm always getting negative sign. For n is odd, I'm always getting positive sign. So this is another way of generalizing addition theorem for n events. And this particular formula and this particular thing is also known as inclusion-exclusion identity. Now, it might look scary to those who don't like math, and if you have not done math before, don't worry about it. We don't need to use all these formulas. We have derived the formulas of addition rule for 3 events, 4 events, 5 events, and up to n events. But do we actually need to use all these scary formulas to calculate these probabilities of at least one of them happening? We don't need. What is the way out if we don't want to use these mathematical formulas? Can you think of any way out to find out the probability, suppose for 3 events or maybe for 5 events? We will cover how to compute the probability of at least one of the event happening when the number of events are greater than 2. Or for 2 events also we can use that particular trick, which is quite simple to use. We will be discussing it in a later video. Till that time, keep watching. Happy learning. Thank you.